So hi guys, welcome again to another video, and for this video I'll be summarizing the chapter 8, which is entitled Subnetting IP Networks. So for the first one, we have broadcast domain. So what is broadcast domain? So the broadcast domain is each router interface connects broadcast domains, and broadcasts are only propagated within a specific broadcast domain. So I'll be discussing to you the problems with large broadcast domains. So first, we have the slow network operations due to the significant amount of broadcast traffic. So for the next one, we have the slow device operations because the device must accept and process each broadcast packets. And the next one, we have solution, and it is to reduce the size of the network to create a smaller broadcast domains in process called subnetting. So these smaller networks space are called subnets. So the reason why we do subnetting is the network administration can group devices and services into subnet that are determined by a location. So also, the network administrator can group devices and services into subnet that are determined by the organizational unit. And for the last one, the network administrator can group devices and services into subnet that are determined by the data type. So let's proceed to the next. Here are the formulas in getting the subnet. So to calculate the number of subnets, the n is equal to the bits borrowed. So here is the bits borrowed, and we'll just do it, raise it into the power. So borrowing 1 bit is equals to 2, and borrowing 2 bits is equals to 4, and borrowing 3 bits is equals to 8, and borrowing 4 bits is equals to 16, and borrowing 5 bits is equals to 32, and borrowing 6 bits is equals to 64. So this is the number of bits, like here. So we got 1, 2, 3, 4, 5, 6. And for borrowing 7, we have here 0, 2, 4, 8, 16, 32, 164, and 128. For all the values here. For the next one, we have the length of the subnet mask. So one of the subnet has further divided create 8 smaller subnet of host each. So we have it each will be divided by the 30 hosts, and it varies into their different sizes. So here is the VLSM subnetting scheme. So this is how we get the subnetting or the VLSM. We have the network portion, the host portion, and the dotted decimal. So, and we have here the ones, the unused available, and 3 more bits borrowed from the subnet 7. So that is for the subnetting a subnet. And the next one, we are planning to address a network. So primary consideration when planning a address allocation. So we have the planning address allocation, and first we will be preventing duplication of addresses and monitor the security and performance. And for the last one, will be provide and control access. So that's all for this video in chapter 8, and thank you for watching. See you again on the next video. So additional for this chapter, we have here the creating subnets with the 16 prefix notation. So here is the prefix length. We have the subnet mask and the network address and the number of subnets and the number of hosts. So the subnets here is determine what value for this one. So for the first one, we have the 17, we have 2, and for the 18 we have 4, and for 19 we have 8. And this is just a normal subnets, and this is the number of hosts. So for the next one, we have the creating subnets with 16 networks. So first we have just 16 prefix, and now we have a 16 network. So we'll be borrowing 1 bit to 14 bits, and you will just raise it by the number of the bits. So first one, we have 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5, 2 raised to 6, and so on until it reach 2 raised to 14. So that H is the answer for this borrowing the bits. So for the next one, we have the calculating the host, and just like in the first one, we have the 2 raised to the n, where the n is the host bits remaining. So here we have the 172.16.00000000, and so on. So we have the 9 bits remaining in the host field, and we have 2 raised to 9 equals to 512 hosts per subnet, and 2 raised to 9 minus 2 is equals to 510. So that's the valid host for per subnet. So here is the range for the 172.16.0.0 with the prefix notation 23. So we have here the given network address, the first host address, the last host address, and the broadcast address. So that's all for this video, and thank you again for watching.